If you pour concrete without a strict system, you leave your structure vulnerable to trapped air, weak joints, and serious degradation. But if you control the variables, you get a clean, flawless finish that will bear weight for decades. This checklist outlines 3 phases of a perfect pour: pre-concreting, pouring, and post-concreting. Every item is based on the IS 456 standard. Before concrete hits the site, you need 3 documents: approved structural drawings, an IS 10262 mix design, and this checklist. Winging a concrete pour guarantees expensive rework. Following this checklist ensures exact structural integrity from the foundation up. Let's look at exactly what needs to be checked. Phase 1 is the pre-concreting setup. Start by inspecting your formwork. The shuttering must be perfectly aligned to your center lines and completely sealed so no cement slurry leaks out during the pour. Next, check the interior surfaces of the formwork. You must apply form oil evenly across every panel so the wet concrete doesn't bind to the wood or steel as it dries. This schematic illustrates IS 456 Clause 26.2.5. You need to cross-reference your reinforcement drawings against the actual steel on site, verifying the bar diameter, the spacing, and the critical lap lengths where 2 rebars meet. The site supervisor then needs to physically inspect the steel framework. This means measuring the distance between chair bars to ensure the top mesh won't sag, and pulling on the binding wire to confirm every joint is tight. During this inspection, verify that the reinforcement steel is completely isolated. It must never directly touch the formwork. This before and after illustration shows why. Clause 26.4 requires properly sized cover blocks to elevate the steel. If the steel touches the edge, moisture will eventually reach it, causing the rebar to rust and expand, which cracks the concrete from the inside out. Before you sign off on Phase 1, secure all electrical conduits and plumbing sleeves into their exact permanent positions. Skipping these pre-pour checks locks hidden structural flaws deep inside the slab. Once the concrete hardens, those mistakes become permanent. Phase 2 begins the exact moment the transit mixer arrives. Log the arrival time immediately so you can monitor the concrete's initial setting limits. This diagram shows the mandatory slump test under IS 1199. Before accepting the batch, you pull a sample to verify its workability. If the slump falls outside your mix design parameters, you reject the truck. If the slump is too low, site workers will often try to add extra water to the mixer to make it flow easier. Do not allow this. Adding unauthorized water destroys the calculated water-cement ratio and ruins the concrete's final strength. While the approved mix is pouring, prepare standard concrete test cubes according to IS 516. Label each cube with the exact date, the concrete grade, and the specific location on site where that batch is being poured. Looking at this cross-section, you can see the absolute maximum drop height for wet concrete. The free fall must never exceed 1.5 meters. Dropping it from higher causes the heavy aggregates to separate from the cement paste. As the concrete fills the formwork, use a needle vibrator immediately. Insert it vertically at regular intervals to drive out trapped air and ensure the mix is fully compacted. This cross-section shows exactly what proper continuous vibration does. The trapped air bubbles escape rapidly to the surface, creating a dense, solid mass. Poor vibration technique leaves those voids trapped, resulting in honeycombed sections. The actual structural strength of your building is built precisely in this window, entirely dependent on how you control the mixture, the flow, and the compaction. Phase 3 starts 24 hours after the pour is complete. Return to the site and carefully inspect the condition of the formwork before planning any removal. This calendar highlights IS 456 curing timelines. Cure for a minimum of 7 days for OPC, or 10 to 14 days for blended cement. On days 7 and 28, crush your sample cubes. Logging these compression results proves your target grade. Once the shuttering is removed following the IS guidelines, perform a final visual inspection. You are looking specifically for any signs of honeycombing, thermal cracks, or surface defects that require immediate patching. Concrete does not reach its target strength on the day it is poured. It only reaches that required durability if you strictly follow this post-pour curing timeline. Completing these 3 strict phases results in a structural pour that is safe, defect-free, and fully IS code compliant. You've accurately measured the reinforcement, maintained the chemical balance of the wet mix during the pour, and proven the final strength through meticulous 28-day curing tests. Elite construction quality is simply a byproduct of rigorously following standard operating procedures every single time you mix cement. To implement this standard on your own site today, download the full Canada RCC checklist below, share it with your site teams, and subscribe for more complete IS-compliant workflows.